also a response to this catastrophic situation that I've imagined. Only here you don't need so much imagination. This is real. Water use, water needs in Indonesia are completely different than we have here in the developed world, and I had the opportunity and support to look at how an alternative to water practices could be developed in a very small context in Yogyakarta. So this is Yogyakarta, and in particular the Terban district with the Kota River running north-south, and this is the district where this water intervention occurred. Now the water in Terban and Yogyakarta is a multi-valued feature. On the one hand, if you are rich, well, you can swim in the best water you can imagine. There's a hotel, luxury, and if you're middle class, well, then you don't have to worry about water problems. You can drink water from bottled water. You don't have to worry about dirty water. But if you're not in that category, then this is your water reality. You swim in the Kota River. That's where you do your laundry. That's where you do your bathroom, and it is like a toilet. It is literally a cesspool. We measured it many times. It is outside of any scope of usability. And then the last vector of water use are the water wells that have traditionally been the water sources for drinking water. And today they are contaminated. They are periodically contaminated, meaning that some days it's very good, and some days it's very bad. And the way they found out if it's a good day or a bad day is someone takes the water, tries it, gets ill. Other people see this person's ill, so they wait. And then they try a few days later again. So they use the human being as a sensor. Terrible situation, right? It's like illness prevailing all over. Anyway, so what we did, and when I say we, I'll show you the team in just a moment, is we went to Terban and we picked out 14 sites to observe the water column over time, over a year. And see, can we understand something of the patterns? And can we respond to this knowledge that we produce? That's the idea. And so all the wells are different. Some of them private wells, some public/community wells, some close to the river, some up on the incline, to get an idea of how the water behaves. Here's the team. This is Sigit in the middle, Dr. Rina, and Yogyakarta, the local PI. And so what we did is we tried to use the best available technology that we could get. The best available means we had to bring it with us in a very laborious process. I was thinking about bringing high-tech equipment into Indonesia. You had to pay people to bring it in. Complicated story. So anyway, optical biosensing. The point is that what used to be done in a complicated laboratory can now be done on a desktop. So you don't need the laboratory, you don't need the lab technicians, you don't need the infrastructure. In a country that has failing state infrastructure, these new biotech technologies can be very effective because you can sidestep institutions that no longer operate properly or that are too cumbersome. And so what this system does is it can detect coliforms in water quickly and precisely. That's the bottom line. So it's an indirect procedure. There's a growth medium. We put in an incubator, and overnight we'll find out how good the water is. And so here is this box on the right-hand side. There's an incubator working right now. Network up into the internet. It has a weather station. I'll show you that in a moment. And battery backup and voltage conversion. Boom, boom, boom. There's a whole system. And what's interesting, this is situated in the local healthcare unit in Yogyakarta. So this was thanks to India Maharika, who made arrangements that we could work with the lowest level of government, the Puskesmas, which is the interface to the public for healthcare needs. So we put this high-tech biosensing system basically into the local doctor's office. They had no space for us, so they put this equipment into the prayer room. The window on the other side where I'm facing is looking at Mecca, so people would come in and pray at the same time the measurements were going on. So it was a very strange relationship. It was welcoming to the new technology, yet it wasn't clear how we could integrate it. So we'll look at So this is the infrastructure. So as a part of a larger framework, there's something at that Puskesmas that I showed you there. Then there's a local server, so the data goes to a place in Indonesia, in the city, where we keep all a record of all the events. And then we have a system connecting to a server in the US, a big fat Amazon server for backup. This is a problem. We'll talk about that later. And then we have mobile media, such that the information can be brought out to the public. Now this is new. Prior to our project in Terban, if there was a water problem and the government would make a measurement, it stayed on someone's desk. It did not go out. And now there's a website where there's information that can be looked at by anyone who has it. Everyone has a phone. So this is no longer like, oh, you don't have an iPhone. No, everyone has a mobile phone. We experimented with various ways. Web-based, SMS, there's a whole story there that I cannot go into. But anyway, the point is that the IT network, the node, allow one to break an established procedure of keeping information in closed circles. And just by diligently open, like the valves that I showed you, by opening and closing the right valves at the right time, you can open forces. So this is a way that we were able to open forces. Another thing that we found, and there was new knowledge for Yogyakarta, is that we were able to, because we ran the project for almost a year, we were able to look at the wet season and the dry season. And so we found that each well behaves differently in the wet season and the dry season. There's actually 3 categories. Wells that have higher contamination in the dry season, and wells that have higher contamination in the rain season. And so now what we tell them, this well, when it's raining very hard, you have to watch out. Go to the other one, right? This is knowledge that was somehow available in a haphazard fashion, and now we were able to nail it. We were able to put it down because of the system that we built. We were able to add new knowledge to the local ecological knowledge, right? Now, the next step that we wanted to do was find out how can we combine that? How can we bring this knowledge together with the local water practices? And I'm not going to talk about that now because we don't have time, but I'm just going to say that is a chapter, an interesting one, that if someone's interested, we have publications on this. I'm going to step aside from that so that we can move to the actual urban intervention that follows this knowledge. Here's an example of the other well. So this one is in the dry season. So blue is rainfall, and green are the E. coli measurements. And you see this one, as opposed to the other one, has a different signature, right? So, okay. So now we found out that you can drink the water. Wonderful. We can say very precisely, don't drink the water. What do you do in a situation where you tell people they cannot drink water? Do you give an alternative, right? So we got together as a group. This is a meeting with the community members. And we said, we need a solution. We need to not only know about this water, but we need to respond to it. And so we decided, and this is, I had research money, and so basically I stole from the research money to do this fancy data, blah, blah, blah thing, and there was something left over. And so we said, you know, okay, I did my work, now we're going to do something else. So we're going to make a new water well for the Terban district. So this is what this is. So we found a place in that community meeting, they organized a piece of land, and found a piece of land, they said, here you can do something. And it was partly destroyed by the 206 mountain rock eruption. This is what it looked like, unkempt, just wild. But it had a fish pond in the front. And the fish pond is like the garbage can. So when the food are left over, just throw the food in there and the fish eat it sometimes. And so this is an interesting place. There's a water problem here. We can respond to this water problem in this situation. And so the first step was we needed to remediate the water well so that we could get water and process it as quickly as possible. So there was a well nearby, and this was supposed to be the Belik Ayu, the beautiful spring. And what's interesting is that, according to the local ecological knowledge in Terban, this was the best water you could have. We tested it, and we found it was full of bacteria. And so what was interesting is that the local ecological knowledge was no longer able to find the best. And this is a problem when you have industrial contamination that can no longer be sensed. Then many of these local ecological practices fail to operate properly. But, I mean, they're very keen if you can hear, if you can see, if you can sense, then they can be very precise and beautifully capture the essence of a resource. But you cannot smell the plug in minute concentration. So it failed. So what we did is we dug this, these two guys, they weren't actually doing it, it's 10 meters deep. Dug it by hand, okay, deeper, so that we get to a better source, but still down at 10 meters is not good enough. So, that's what the well then looked like. So these pipes on the left go down. On the right, this is the old well. So a well is just basically some pipes going around.